All right, now let's talk about problem number 9. In problem number 9, we want to determine whether Rolle's theorem applies to the function f of x equals cosine of 4x on the interval pi over 8 to 3 pi over 8. And if so, find the points that are guaranteed to exist by Rolle's theorem. Okay, let's review Rolle's theorem really quick again. It says that if a function f of x is continuous on this closed interval and differentiable on this interval except the open interval, and the endpoints, the functional value of these endpoints are the same, then somewhere in between those two endpoints, there's a point x where the derivative of this function is 0. So a couple things we need to check to see if Rolle's theorem even applies here. And the first one is this thing a continuous function on this interval? Well, cosine is a trig function, and cosine just happens to be a trig function that is continuous everywhere. So if it's continuous everywhere, certainly it's continuous on this closed interval. Similarly, cosine is a trig function that is differentiable everywhere. And if it's differentiable everywhere, then certainly it's differentiable on this open interval. So the only thing we really need to check is, what about the endpoints? Are the endpoints the same, or the functional value of the endpoints the same? So I need to test what is f of pi over 8, and what is f of 3 pi over 8. So f of pi over 8, if I plug it in over here, I get cosine of 4 times pi over 8. Well, cosine of 4 times pi over 8 is the same thing as cosine of pi over 2. And cosine of pi over 2 is equal to 0. Okay, what about f of 3 pi over 8? Well, that's cosine of 4 times 3 pi over 8, which is the same thing as cosine of, let's see, that would be 3 pi over 2, which is 0. So they are the same. So Rolle's theorem does apply because it's continuous on the closed interval, it's differentiable on the open interval, and the endpoints give me the same functional value. Okay, so Rolle's theorem applies. That means that somewhere in between pi over 8 and 3 pi over 8, there must be a place where this function's derivative is 0. So let's find that place. That's the last part of this problem, is just find the place where this guy's derivative is 0 that lives between pi over 8 and 3 pi over 8. All right, so let's take the derivative. So let me rewrite the function real quick. F of x is cosine of 4x. So the derivative, f prime of x, is equal to, well, the derivative of cosine is negative sine of 4x times the derivative of 4x, which is 4. Okay, so here's my derivative. And I want to know, where is this derivative equal to 0? So I'll set it equal to 0. And this, I could also write this as negative 4 times sine of 4x. I could divide both sides by negative 4, and it's the same. So I get that 0 is equal to sine of 4x. Now, we need to know, where is sine of 4x equal to 0? Well, an easier question to answer maybe is, where is sine of x equal to 0? Or in other words, what makes sine 0? Well, the first thing that makes sine 0 is 0, right? But what would x have to be here for 4x to be equal to 0? X would have to be 0, right? So if this x were 0, then I'd get sine of 0, which is 0. But wait a second, 0 doesn't live in my interval. I'm looking for something between pi over 8 and 3 pi over 8. So 0 is not the one I want. So let's move on. What else, sine of what else gives me 0? Well, the next one would be sine of pi is 0. Okay? So sine of pi is 0. But what would x have to be for 4x to be pi? I suppose x would have to be pi over 4, right? So pi over 4 times 4 is pi. So if x were pi over 4, I would get 0. Is pi over 4 in this interval? Well, it's bigger than pi over 8, and 3 pi over 8 is bigger than 2 pi over 8, which is pi over 4. So yes, pi over 4 is a solution that's in the interval. The only other question I have to ask is, well, is it the only one in the interval? Well, what would be the next thing? Sine of what would be 0? The next one would be 2 pi. So x would have to be pi over 2. And is pi over 2 in my interval? Not quite. It's bigger than 3 pi over 8. So no, it is not. So this is the only x in this interval for which f prime of x is equal to 0. And so that's the one point that's guaranteed to me by Rolle's theorem. So the answer to this problem is x is equal to pi over 4.